All right, so in this one here, we're going to take a look at simple and compound interest and how they work based on the simple interest formula. So some definitions to get out of the way. Interest, that is money paid for borrowing money. So if you borrow some money from somebody in banks and things like that, financial institutions, they're going to want some more than what they lent you. They're not just going to give you $1,000 and say, oh, hey, yeah, pay us back $1,000. They're going to want more money. So this is what that extra money is, and it's generally calculated by a percentage. In the same note that when you give the bank money or you give an investment firm money to put into something, the money they pay you back is also interest. So you're loaning them money, you're letting them borrow your money and they'll pay you for that. Or you're borrowing money from them and then you pay them extra for that. So that's that extra money that you pay to in terms of the borrowing. The interest rate is the percent of the original money paid or earned over time. And I noted there, underlined original, because the original value can change depending on the type of investment you're looking at, if it's a simple or compound interest investment. Note, the interest rate will always be expressed per year. You might not be paying per year, but it is expressed per year. Now, simple interest is the simple version of interest. What happens is you calculate the interest on the principal only. So just to jump ahead a little bit, principal is the original money invested or borrowed. So if you borrow $1,000, that's the principal. And then you pay interest on top of that. So simple interest is calculated this way. The interest itself is the principal, so the original money borrowed, times the interest rate, the percent, generally changed to a decimal for convenience, and then the time frame that you're doing this over. So I equals PRT is the simple version of the formula. We've already talked about principal, and so now let's move on to beyond simple interest. Now, simple interest, again, just pays interest on the original value. Compound interest compounds. It builds upon. It builds upon the principal and then any previous interest that you've paid. So if you've invested $1,000 and you got paid $100 extra in interest, so now you have $1,100. The next time they calculate your interest, they're going to calculate it not on the original 1,000, but on the 1,100 in total that you have. So compound interest keeps building, and it keeps adding the new interest in to the calculation to build the next set of interest. That's why compound interest is awesome. We talked about that in class. Compound interest allows you to build over time. Eventually, you're making interest on interest on interest. You're going to make more on interest than you are on your original value. Amount focuses on the total value of an investment or loan at the end of a period of time. So that is the principal value plus the interest. So if you're paying this off, if it's something you borrowed, that is the original value plus the interest that you have to pay. If this is money you're investing, then this is the amount you invested plus the interest that you made. So the amount is the original value plus the interest made. The last concept here, term that we want to cover in this section, is the compound period. And this is just the time in which the interest is added to a compound interest investment or loan. So this only has to do with compound interest, not with simple interest. But if you invest, or say you borrow from your credit card, you use your credit card, and so the period might be, and in that case is monthly. Every month they calculate interest on your money owed. And so the period is monthly. And so that's how often it's happening. Let's take a look at some examples of working with these. We'll start with simple interest, and then we'll move into compound interest, which is just an amalgamation of some simple interest calculations. So simple interest is pretty straightforward. You just have to identify your principal, your interest rate, and your time. And so something convenient to do, P, R, and T. We just write them out. What's the principal? So John borrows $45,000 for 3 years at 2.5% simple interest. Note that when you read these questions, if it says simple or compound interest too, but he's paying simple interest. How much does he have to pay back? So he borrowed $45,000. That's his principal, the initial amount of money that he borrowed. The 3 years, that's the time frame that we're working with. And it's at 2.5%, and that's 2.5% a year. We always like to write this as a decimal because not all our calculators have a percent button. You could type it in your calculator as a percent if you have a percent button, but in general, it's good practice, and you'll see why, especially when we move on to the next section, which is the compound interest, to change this to a decimal. If you're not sure what is a decimal, divide by 100. But I don't have a calculator with a percent button. Even though this is a fancy dancy calculator with all these fancy buttons and like a million features, it does not have a percent button. I can play Doom on this thing and Snake and Tetris, but I can't press a percent button. Clear off the old stuff. $45,000 times 0.025% times 3 years, 3,375. That is going to be what it is. I probably should have wrote down the equation here. Interest is principal, so 45,000 times the rate times the time. It's that easy though. 3 numbers multiplied together, and again I got $3,375. That is the amount of interest that he has to pay, but that is not the amount of money he has to pay back. He borrowed $45,000, he's got to pay that back too. So the amount equals the interest, 3,375, plus the principal. So we got to add those guys up. 45,000 plus 3,375. That's going to be 48,375. That there is my final result. John is going to have to pay back $48,375. $45,000 that he borrowed plus $3,375 in interest. Let's take a look at a couple more here. In the next case, we have a different situation in that we're working, instead of years, we're working in days. So here we have Reba investing $25,000 in a 120-day GIC. I put that on screen. There we go. So Reba's investing $25,000 in a 120-day GIC. So approximately 4 months, give or take, at 4% simple interest. How much interest did she make? So here, we got to remember that the interest rate is given per year. Well, we're not doing a full year. We're only doing 120 days in this guaranteed investment certificate. And oftentimes you can get a 90-day, 120-day, you can get a certain time frame that might be shorter than a year or longer than a year, depending. But in this case, it's just a short-term investment that she puts it in, and it locks it in at that 4%. So how much is she going to make? Well, PRT, her principal, $25,000. Her time is 120 days. And now the last part here is that 4% But there's a problem because this is 4% and this is 120 days, not years. This is in years, the percent per year, but this is in days. So what do? Well, it's only 120 days of the year. How many days are in a year? Financially, we'll base it off 375. So we just divide this by 365. Trying to make nice, pretty numbers, but it's not. 120 divided by 365, that's going to be the time. So it is 0.3288. I'm going to go to 4 decimal places on this one. So there's our time. Why did we divide? Because again, 4% per year, but she's not investing for a full year. She's only investing for 120 out of 365 days. So we divide 120 by 365. That's the portion of the year she's investing for. She's only investing for 0.3288 or 32.88% of the year. So that is the part of the year she's investing at 4%, the $25,000. I equals P R T. There's our I equals PRT. And when we plug that all into our calculation device, 25,000 times 0.04 times 0.3288, we get 328.8. Now it's dollar value, so I'm going to toss that extra zero on the end. $328.80 she made in that 120 days, about 4 months. So in 4 months, she's able to make $328 by just letting her money sit there. And that's, again, our final answer. Why aren't we adding in this case? Well, remember in the last case, we asked how much did, what was his name? John had to pay back. John had to pay back money, so he had to pay back his original 45 plus the 3,000 and some dollars. In this case, we just want to know how much money did Reba make. So make sure you're reading your questions, paying attention if it's asking for the total amount or the interest. Now, let's jump it up a little bit. Let's look at this compound interest. Our money's going to make money. So if we make some money, that money is going to make money on the money we make, and we're going to keep compounding that value. So I kept it simple on this one. We got Matt investing $2,000 for 3 years, 4.7% compounded annually. How much interest did Matt make? Well, every year he's making 4.7%. And it's compounded annually, so that means that every year they're going to pay off that and then add that on. So compounded annually means at the end of the year we add on whatever interest we made. So the initial value, the interest, and the amount are the three values we're going to, I should say year too, the year. So, year one, his initial value was $2,000. The interest is going to be 2,000 times 0.047 times 1 year. There's our interest calculation. What's that equal? So let's see, how much does Matt make after 1 year? $2,000 times 0.047 times 1. He makes $94. So after his first year, Matt's made $94. So what's his amount? 2,000 plus 94, or 2,094. So there's his amount after 1 year. He's made $94 in interest. Now the next year, because we're compounding, we're not going to just pay another 94 and then another 94. That would be simple interest. Compound interest takes this value here and puts it in. So now 2,094 is his initial value. And so we have 2,094 times 0.047 times the 1. And when we calculate that, we make 98.42 if we round it. So he's made $4.42 more. It's not bad. So we add those up, and we get 2,192.42. That's his second year value. So he's made a little bit more money. Finally, we got a third year. Year 3, again, starts with the 2,192.42. So his interest, still paying 4.7% for 1 year. Is going to be 103.04. And you see we keep going up. We've gone up now $5 almost. And this keeps progressively going bigger and bigger and bigger. Each year he's going to successively make more money. And eventually, in the long run, he's going to make more money in interest than he is based off his original investment. But we're just looking at how much interest did he make over that period of time. So let's find out his final amount here. This will give us his final amount, which is 2192.42, $2,295.46. So he's made a few bucks extra based off simple instead of simple interest. So he's made that right there. Now, how much interest has he earned? So this is how much is in his pocket. His total interest or amount, okay, is what we're looking for in this case. So the amount, A equals, sorry, we're not looking for the amount. We have the amount. The total interest is just going to be the amount minus the principal. There we go. So the total interest is the amount minus principal, which is $2,295.46 minus $2,000, or $295.46. So there, that's a 46, by the way. There we have the amount he made. So he made $295.46 in interest. And so in this case here, versus simple interest, he's made more. In simple interest, he was making $94 a year, which would have totaled out to 94 times 3. Every year he would have made $94 plus his $2,000. $2,282 is what I calculated. So $94 each year of an interest times the 3 plus the original amount, $2,282. So he made an extra $13.46 in interest, and he ends up with that little bit extra money. Over time, again, this builds and builds and builds, and then he makes lots and lots of money.